23 and? Okay. So it says something. Oh, that's not right. The integral from 0 to 2 pi, 0 to a, 0 to square root of a squared minus r squared, r, dz dr, d theta is the volume of a sphere of radius a. So it's just a true-false question. And so let me just ask you this first. So I'm assuming if you got a true-false question wrong, you could figure out the correct answer. Okay. So what do you think? What did you think this should be?
Was the half of the
Yes.
things? Oh.
So let's just talk about it. I think you had the right realization there. So if you have a sphere of radius a, right? You're going to have this like this. Here's a. And so if you wanted it, so you can integrate, right? So volume is the triple integral over that of dv, right? And so you could set up your bounds. This can become r d z dr d theta. Again, you're going to integrate from the bottom to the top, right? And then it'll be 0 to 2 pi, 0 to a. So that's fine, and that's what's here, right? But if you want the whole sphere, this top is z equals the square root of a squared minus, well, minus x squared minus y squared, but that's minus r squared, but the bottom is negative that. And so this isn't the volume. The volume would be negative square root of z, or a squared minus r squared. So that. Does that make sense?
Yep.
Yeah, so just be on the lookout for that if you tweak, if you change, right? If we went instead, if we had this, but we went from 0 to pi, what would we get? We'd have half of the sphere again. It'd be the
Right half.
0 to pi. Yeah, I guess it's the right half. And then some other tweaks on that. Okay, good. All right, so 21. So this one says, so the directions are find the volume of the solid using a triple integral in cylindrical coordinates. And so so it says, find the volume of the solid in the first octant lying inside the sphere and above the region in the xy plane defined by this, right? By this. So this is region, so inside this and above this thing in the xy plane. So again, same, you're in the first octant. They got a sphere of radius 2, right? And then what is this thing corresponding to? The circle of radius. Well, it is a cylinder, but they're really just saying above this region in the xy plane is the way they worded it, right? So you're saying you have this circle of radius 1 down here, and so we're not looking for the whole amount of this. We're just looking for the piece that's inside of there, right? So the volume of that. And so we can kind of ignore the rest of this sphere, and we just want the part of this sphere in there. So we have a top of it. What's the equation of that sphere? I'll just write it this way for now. Oops. We'll come clean that up in a second. But we just want to integrate over this volume, right? So over that region. So the volume is the integral over that Q of just dV. If we switch to cylindrical, we get that, right? So the x, y are just controlled by that circle of radius 1, so what are our bounds for r and theta? R goes from
0 to 1.
0 to 1 and theta
0 to pi over 2.
to pi over 2. Is that okay with everybody? Just doing that 90-degree swing. And then your z's go from 0, right? Because you're under the sphere, but in the first octant. So from 0 keeps you in the first octant until you hit the sphere. And we just saw it over there. What's the equation of this sphere in terms of cylindrical?
4 minus r squared.
4 minus r squared. Is that okay? Again, the x squared plus y squared is r squared. So you got r squared plus z squared. So the top of the sphere is root 4 minus r squared. And then integrate from there. Are you okay with the integral from there, or?
I just got the r wrong. I
Okay.
got r is 1 to 2.
Oh, okay, that makes sense. Yeah, you're stuck inside of there.
Okay.
If it was outside of that sphere, then you would have been right, right? So
Okay.
you could have asked the same question where you basically have that same picture drawn, but instead of the part that's inside, we want the outside, right? And then you'd integrate from.
So if that is the outside one, should I get top?
The top would still be that sphere sitting
Okay.
over it. It's like you have the sphere and then you hollowed out the core of it.
Gotcha.
And then your integral would be right for that. Okay. Other questions? All right.